Okay, in this video, I'm going to go over the 6.4 notes and the 6.4 homework. So 6.4 is proving triangles similar by side, 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 and side, angle, side. So remember, we've already proved them similar by angle, angle. So here's some vocab. The ratio is a comparison of two numbers. So we do that a lot in doing these proportions. Proportions are when you set two ratios equal. And remember that similar polygons have the same angles but different side lengths. In fact, the side lengths, the corresponding side lengths are going to always be in proportion if they are similar. And when you reduce that proportion to simplest terms, that is your scale factor. Okay, we have this first theorem, which talks about side, side, side similarity. So it tells us that if the corresponding side lengths of two triangles are in proportion or are proportional, then the triangles are similar. So for this one, let's say, look at the orientation. I'm assuming the orientation is the same for both. So if I had numbers, I would test to see if AB over RS equaled BC over ST equaled AC over RT. Okay, so that's how I would test to see if I have side, side, side similarity. So note, there's no information about angles that you need to worry about when doing side, side, side similarity. Okay, so here's our second theorem. And this is side, angle, side similarity. So when you have this situation, you need to be given an angle that's sandwiched between two sides that are shown to be proportional. So here's our angle. So that's part of it. I have these two angles congruent. So then what I need to have is that XZ over MP equals XY over MN. If I can show that, then I can prove that these two triangles are similar by side, angle, side theorem. Okay, let's go on. So here they say, use the side, side, side similarity theorem. Is either triangle DEF or triangle GHJ similar to the first triangle, triangle ABC? So first I tested triangle ABC and triangle DEF. So I said small, to test it, I'm saying small over small, and then the median is 12 over median of the right triangle is 9 over 16 over 12. So can these reduce to the same scale factor? And when I reduced them, so I divided the top here by 2 and the bottom by 2 and got 4/3. I divided the top 12 by 3 and the bottom by 3 and got 4/3. I divided the top 16 by the bottom 12, the top 16 by 4 and the bottom 12 by 4 and got 4/3. Because I have identical ratios, I can therefore say that these two triangles, ABC and DEF, are proportional. And then you have to make sure that you write it the same way. So I went ABC, so smallest over medium, and then DEF, smallest, and then medium. So this is my similarity statement, and this is what allows me to make that statement. Okay, next they wanted us to test the first triangle, ABC, and this other triangle, which we'll just call GHJ. So smallest on the left triangle is 8. Smallest on the right triangle is 8. Oh, that's going to be easy to reduce. Next is 12. The next size is 10. Ooh, I could stop right here because do you see how 8 over 8 is not the same as 12 over 10? So just by doing only those two, I could say that these two triangles, the one to the furthest right and the one to the furthest left, are not similar. Okay, so let's keep going. It says use the similarity, the SSS similarity theorem here. Now, they say find the value of x that makes triangle ABC, okay, they give us the order, similar to triangle DEF. So the orientation is the same, ABC, DEF. So start doing your proportions. So 4 is the small, 4 is the AB. Okay, you can't say smallest because I don't know what this is. But AB over ED, I get that from the first two letters here and the first two letters here. That gives me 4 over 12. That's going to equal BC, which is x minus 1, over EF, which is 18. Okay, so those two ratios set equal to each other, so this proportion is sufficient to figure this out. So what I'd recommend you do is simplify the 4/12 to 1/3 by dividing the numerator and the denominator by 4. Then you're going to do cross products. When you do that, and you multiply 3 times x minus 1, make sure you multiply the 3 by both the x and the 1. Okay, now your job is to isolate the x, add 3, add 3. I'm getting 3x is 21, divide by 3, and I'm getting x is 7. Had you done 8 over 3x plus 1, you would have gotten the same answer of x plus 7. You can test that for yourself. Okay, now we're going to switch theorems. We're going to go to side, angle, side. And it says you are building a lean-to shelter starting from a tree branch as shown. Okay, so here they're starting from the tree branches. Okay, can you construct the right end so it's similar to the left end using the angle measurement? So here are the tree limbs, and they want the right end and the left end to be similar. So look and see what I have. I have a matching angle, 53 and 53. So I can say these shapes are similar if 6 over 9 equals 10 over 15. So what I can do, I can either reduce them both and see if I get the same fraction, or I can just do cross products. And if my cross products are equal, which they are, then I know these two shapes, these two triangles, are indeed similar. And I can also write a similarity statement. So it's GFH is similar to BAC. Okay, so make sure that makes sense to you. That was using the second theorem, side, angle, side similarity. Okay, then we had some extra practice. So it says, is either PQR or STU similar to XYZ? Okay, so you're going to take XYZ and see if it's similar here, or maybe both. So I did the first pairing here, and since I have all three numbers, I'm looking at side, side, side similarity, and I say smallest here is 15 over smallest here is 21, so I'm putting that over here. The next one in order is 25 over 35, and then the last two, which is the largest on the top triangle over the largest on the bottom triangle, is 30 over 42. When I look at these, I can reduce each of these ratios to 5/7. Therefore, I know that the ratios are all the same, so these sides are in proportion. So I can say that this top triangle and the bottom triangle are indeed similar. Now try the same thing with the other two triangles. So this top one again, the smallest is 15, the smallest over here is 15. The next one is 25, and the next one here is 20. Oh, that's a problem right there. Look at this. This reduces to 1, and this is going to be greater than 1. So I could stop right there and say that these two triangles are not similar. Okay, so let's go on, see what else this has to offer us. Okay, here it says solve for x. They are telling you that these two triangles are similar by this similarity statement, and figure out your proportions. So looking at the orientation, I see that they're both facing the same direction. So 20 is to 30, just like x plus 6 is to 21. Okay, so I don't need to add the other proportion, because as long as I have a proportion, which is fraction equal to fraction, then I could figure out what x is. And x is going to be the same either place, because this has the same name. Okay, so why don't we reduce 20 over 30 to 2/3? So do your cross products. 2 times 21 is 42, and 3 times x plus 6 is 3x plus 18. Subtract 18, and you're left with 24 equals 3x. Isolate the x by dividing both sides by 3, and we get x equals 8. So that's all good, and I've solved for x accordingly. Okay, let's tackle the homework now. So look what we have for homework. Check your homework. Verify that triangle ABC is similar to triangle DEF. Okay, so ABC, DEF, they have the same orientations. And they say find the scale factor. So they want us to verify that they are similar. To do that, because you have only sides, you're going to do side, side, side. So the side is 12, so 12 is to 8, just like 9 is to 6, just like 15 is to 10. And when I reduce all of these, I see I can get them each to equal 3/2. Therefore, the scale factor you can write as 3/2, or you can write as 3 is to 2 with a colon in between. Okay, so let's do the same thing for the next one. It's also side, 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 similarity. I'm looking at A, B, C, D, E, F. Okay, so I see the directionality is the same. So 21 is to 28, just like 33 is to 44, just like 18 is to 24. So what I'm seeing is that each of these fractions can be reduced to 3/4. So therefore, the scale factor is 3/4. They are proportional, and I can therefore state that they are indeed similar by side, side, side. Okay, same thing here. It's another side, 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 because I first tried to get angles involved. And since these angles are not the same, I have no angle here, and I can't figure out any other angle. So I have to just revert to side, side, side. So looking at these first two, go for the smallest side here, which is 5, over the smallest side here, which is 4. The next in order is 7 over 6, and then 8 over 7. Okay, so none of these can reduce to the same ratio as another. So therefore, these two are definitely not similar. So then I matched up the first triangle and the last triangle. And look what I'm finding. So 5 over 2, and then 8 over 3.5, 7 over 3. Does that work? Let's see. 3 times that is 30. So I am not saying that that works. So what was I thinking? Oh, I know what I'm thinking. I'm thinking that these two work. So let me change this. So I am definitely changing this. So I am going to say this is a no, so change that to a no, and change that to a no. Now what can we do? We can do not A, B, C, and G, H, I, but what should this be? This should be D, E, F. So make this D, E, I lost my head here. Okay, and what's the ratio? It's not this, but what do you see? I am seeing that 4 is to 2, 4 is to 2, just like 7, okay, is to 3.5, and this is a 7 and not a 1, so I'll put an extra little mark right there. Okay, 7 is to 3.5, just like, and I'll do it over here, 6, oops, let me erase, I'll make that looking better anyway. So this should be a 6, not that, 6 is to what number? 3. Okay, so what is the scale factor there? The scale factor there is 2 to 1. So write this down, because once I move off this, this writing, the writing will go away, and I don't want you to leave confused about that. Okay, so write that down. I'm just going to pause things for a second so that you can do this writing. And so then you know that those two are equal, and I'm going to change my answer key while you are doing that. Okay, so giving you a second to work on that. Okay, so we said no there. Okay, so you should be good. So this should be DEF. This first one is DEF. And the reason being, so I'm just going to do it again myself. 4 is to 2, just like 7 is to 3.5, just like 6 is to 3. Perfect. Okay, so we're okay there. Okay, so let's go down to 14 now. And 14, what am I seeing? Excuse me, not 14, 4. 4, what am I seeing? Oh, here, let me get rid of this. Slide up, my apologies. Okay, so what am I seeing for 4? For 4, we're comparing these guys. So I said 24 is to 18, just like 20 is to 16, just like 16 is to 12. So I shouldn't really put equal signs. So what I'm going to do is I'm going to cross them out, because I'm just trying to test them out. Everything works except this middle one. So that's why it's a no. So you can say that, nope, once I've set them up, now I can see that these guys are certainly not equal. So you can put equal signs initially, and then as you do your evaluation, you're going to cancel them out. Okay, so look over here. If I compare the far triangle, the two far triangles, I'm getting 24 over 30 is to 16 over this 20, just like this 20 is to 25. So is that true? And what I can say is yes, because look what happens. When I reduce all of them, they all reduce to what? 4/5. So you can say yes, since 4/5 does equal 4/5, and then here's your similarity statement. So that should be good to go. And you can, now you probably should definitely set these guys equal. So put these as equal signs. So again, once I move off this page, the markings are going to go away. So make sure that you copy down the markings that you might need. Okay, that brings us to the next problem. So let me slide down. Let me get rid of this markings. Okay, markings are gone. Sliding down. Okay, so it says verify that these two triangles are similar. So what do I see? I see they have a common angle. So then I'm going to test, is 4 over 6 equal to 6 over 9? And so you could reduce it to the scale factor, or you can say 4 times 6 is 36, and so is 6 times 9. So that works out. So the scale factor is 2/3. So they are similar. Look at 6. Same setup. So these are both side angle side. The angles are the same. So is 28 over 16 equal to 21 over 12? And they are. So they both reduce to 7/4. I could also have done the cross products, but that would have been a lot of math, and make the same conclusion, that because they have the same scale factor, they are similar triangles. Okay, look at 7. So when I did 7, I tried to go from this one to this one. So 45 over 20, 63 over 28, and 54 over 26. So these two can reduce to 9/4, but 4 does not go into 26 evenly, so this cannot reduce to 9/4, so they are not similar. So these two are not. Then I did 45 over 25, 63 over 35, 54 over 30. And I looked, and each of these can reduce to 9/5. So yes, that is my scale factor, and then here could be my similarity statement. Okay? So make sure that you understand that. Okay, is there enough information to determine whether the triangles are similar? And if so, write a similarity statement. Okay, so I've got this matching angle here and here. Ooh, I have a side here, but not a side here. So I can't do side angle side, and therefore there's not enough information. Okay, look at this guy. They have a common angle C, because this is the top triangle, and this is the big triangle. So look what you have to do. 15, which is the side here, over 27, which is the big triangle side, equals 20 over 36. Make sure you know how I got those numbers. So can I reduce these to similar ratios? And I can, because 3 goes into 15 5 times, 3 goes into 27 9 times, and 4 will go into 25 times, and 4 will go into 36 9 times. Again, you could have multiplied these together, cross multiplication, and if you got the same answers, then you would say that they are similar. So now write in your statement, GCD is similar to FCE. Okay, I'm going to go one more place. Okay, here comes 10. So look at these guys. So since neither of these angles, well, since this angle equals, okay, so 92 is equal. Okay, would 41 go here? So look, if I add 41 to 57, do I get another 88? So let's do this math. So let's see. So I know I need to have 88 degrees left. Yeah, so could I make this angle over here be 41? What is 41? What is 41? And, okay, so let me just hold on one second. I'm just going to pause this for a second so I can fix that. Okay, so try it again. What is 41 and 57? So if I made that C angle 41, this would be 8, and this would be 98, and 98 plus 92 is too big. So therefore, I cannot make this angle 41, and therefore, these two shapes are not similar by side angle side. So this is a no. Okay, so if you want to write that down, you can. I'm going to turn off the pen right now. Okay, look at this next one, 11. So do you see how even though these sides and these sides are not the same, they're going to have the same proportion. So therefore, by side, side, side similarity, you can say, yes, they are similar. What about this one? Here's a right triangle, so they both are right triangles. So is it true that 3 is to 6, just like 4 is to 8? And the answer is yes. So by side, angle, side, you can prove that true. Okay, look at this next one. So I can see that I have right angles here. So when I have this side, but I don't have this side, I have this side, but I don't have this side. So that's going to be a no. I can't prove it that way. And then look at this. If they told me this is 9, and this has the same markings, that means this is 9. If this is 6, and it has the same markings, this is 6. So is it true that 9 over 6 equals 6 over 4? And I can reduce them both to 3 halves, or I could have even done cross products and got 36 equal 36. There are no angles involved here, so I can say yes, that they are congruent by side, side, side. Okay, let's continue on. Okay, this I had done in class, so I'll do this again. Okay, here's your fallen tree example. So when you look at this, this is the little triangle here. This is the big triangle here. They both have right angles in common, and they both have this, what they call a toe angle in common. So let's do our proportions. Here's the hypotenuse of the big guy over the hypotenuse of the little guy. Here is the base of the big guy over the base of the little guy. So I changed this into, I just reduced it, I can reduce it all the way down to 7 halves. And then 2x equals 70. So that means that x equals 35. So we can say by side, angle, side, similarity. So this, I should have said side, angle, side. So I can write that here. Side, angle, side. I can prove that these two shapes are indeed similar. And then once I prove that, then can't I say the length of that tree is going to be 35. Okay, so that ends this lesson. So hopefully this is clearer to you now.